experiments. Okay, I would have called it as experiments. A small one creating 3 periodic tasks. I will explain you what they are supposed to do. Very simple one, just to get a make your hands dirty and preparing you for the midsem exam as well as for the final lab exam also. Some of this you can do. This is just to, I will explain anyway. And then how to configure the GPIO pins for reading inputs. Mostly some of you might have already tried it. But still, I assume those who have not, you are just doing what is done in the class to help them out. These exercises will help you out. So what we should do is from the setup function, you need to call create task thrice with function names task1, task2, task3. So you need to write 3 functions and then pass the function pointer and the parameter to them. Only the period of those tasks are periodic tasks have to be made as 1 second, 2 seconds, 3 seconds. So what exactly it means is if you have seen the OS tasks, you might have seen that a task wakes up every 1 second and runs for some time. This is execution time. Assume that this is the period TP 1 second. So that means it wakes up at this time. Whatever is supposed to be done by the task, it executes it, and then it sleeps for 1 second or whatever time. So this execution time is assumed to be much smaller than the period. So you can assume that the periodic task is waking up every 1 second, though it is actually sleeping for 1 second and then wakes up and does something and then goes to sleep. So I want you to do 3 tasks. One is waking up every 2 seconds, one is waking up 1 second, and then other task is waking up every 3 seconds. So there will be 3 tasks running continuously in the system. Each of them will be receiving an integer parameter. You know that one integer parameter, not multiple, because you can only pass one void star. So you have to pass a integer star as void star. I want you to initialize it to these values just to be consistent across all of us. Then normal that blink LED will be happening in the loop. So let me explain for the benefit of others, those who are not experienced. Now setup function, you know that it enters and then it calls a loop function. So I want you to call create task thrice here, which is creating task 1, task 2 and task 3. So they start running in the periodic manner because the sleeping is taken care of inside the task, so that 1 second or 2 seconds or 3 seconds, you will be implementing it in the relevant function. Okay, you are not passing it as a parameter to the task creation because there is no way you can tell in FreeRTOS to make the task run on a periodic way. But we are simulating it by calling a sleep function inside that delay, or I'm saying delay inside that. Now, after having done that, anyway, this will come, control will come here, which will be going through the loop. So normally what people do is to blink the LED. Okay, in this case, I don't want you to make it blink here because it is going to be, oh, sorry, I'm confusing 2 things. Okay, sorry about it. Okay, here only you have to blink the LED, maybe every 1 second. This will be running continuously, but this task will wake up every 1 second or 2 seconds or 3 seconds, and then they print out messages. They don't again try to control the LED, because LED we can make it control from one task only, otherwise there will be a confusion. So you will be printing it periodically here. Whatever value was passed, it will be incrementing it, and then each of them will sleep for the time that they are supposed to do, and then they print the values periodically. So it will go on continuing, periodic task. There is nothing called a dead, when it is going to be killed. So you have to keep it inside the while loop. Okay, while one. So inside that you have to print the value and then sleep for the time what it is supposed to do, and then of course increment it and print again the next value, then sleep again. So this is what you will be doing it in the each other task, only that sleeping time is different and what it is incrementing is different because each task are receiving different parameters. Those parameters are initialized outside with these values. I hope it's very clear. The task, I'll be sharing the PDF of this document also so that you can refer it. So in each of the tasks, keep printing every, okay, not every 5 seconds, incremented by based on the value. Let me write it. Maybe I made a mistake. Periodically, printing periodically. Keep printing periodically by incrementing the value of parameter passed to each of them, and in X format. So because we are passing it in X, I want you to print it in X so that you know the value what you are passing is only getting printed. You can use printf here, okay, %x and printf. So store the task handle returned by the task create. Okay, now this we didn't do it last time. The create task, whatever the create task create or task, I forget it. Okay, I think task create, X task create. Okay, you are passing different parameters. The last one used to be null earlier, but actually this is the place where when the task is getting created, the free task function, okay, is returning if you pass a pointer, not a non-null pointer, so it's a pointer to some variable, it will write the handle of the task. The reason why I want you to take the handle back is you can use it for some other purpose. Okay, I will explain you what I want you to use it for. So this handle is nothing but an index into the task array. See, just to explain you how task is getting created, it maintains an array of maybe a task record, okay, record or a structure, okay, a structure, C structure. So each of those structures will have some different values specific to the task, okay, whether it is in which state, whether it is sleeping or blocked or it is running or it is different states will be there. So this task, how many number of tasks it can create, it is limited in free task. You know, it is a configurable parameter. I will later on tell you where it is to be configured. Mostly any real-time OS, okay, this free task is also real-time OS. They will limit the number of tasks that can be created while they build the task itself, while they build the OS itself, because the structures that they need to reserve for each of the task is limited because the memory space is limited. So real-time operating systems limit the number of tasks you can run, and that is configurable during the OS building the OS while you getting the executable of the OS. So most probably this may be configurable or it may be predefined by the ESP32 guys. I will dig into it and then let you know. In case you guys know, tell me. Whatever may be, we are only creating some 3 tasks, so that shouldn't be a problem. So what will happen is it will reserve one record and then create the task and then return a handle to the task so that OS can access the task information and do something. Okay, it can call some functions on top of the task handle using the task handle. So I want you to take the task handle and assign it to the 3 variables. You need to define them as like this. This is a built-in data type, and then you need to include task.h also. Okay, I think you might have done it earlier itself because you are doing a create task. In case if it is not done, you need to do that. And then what I will do is I will also share with you the header file, okay, which I have taken it from this directory. You can also, actually it is better you try to look for this header file. Let me explain you why I want the header file to be taken. What they have, ESP32 guys have done is, they have taken the free RTOS and then modified some, may not be modified, but some changes they have done, and then they have extended the free RTOS API also, added some new APIs, and then they are capturing it in different header files. So the prototype of those functions are available in different header file. So if you want to know what functions are supported, how to use them, they are all documented in this header file. You can look for this. If suppose your Arduino is installed, you can look for this particular directory which I mentioned earlier. When you go to files and preferences, in the top you will be seeing this directory. Under this directory, you go to Arduino data and then packages, ESP32 hardware, ESP32, then all this nonsense. Then you will go to this particular directory where you will have all the header files, okay, related to FreeRTOS implementation, as well as, yeah, it's mostly FreeRTOS implementation, which is specifically ported for ESP32. So it will be interesting to know what all functions are supported, what all the header files are there. Only thing is, make sure that you don't make any changes, or by mistake don't edit it or anything. Do not save back even if you open it on a header editor. Make sure do not make any changes, but find, locate some things and dig deeper into it. If you are looking for some function, then you will be able to use it for your projects, or if you want to add something, if you want to do something, if you want to explore further, this is the place to go for. So that's why I'm exposing you to see such directories where you can do something on your own. Okay, so try to locate it and then use the following function to print the task's name. Now the information what I wanted from you is, because you are using the handle, you can use the function which is pc task get task name. Okay, this is the function which is defined in this header file. Also you can see the prototype. It accepts the task handle of type task handle underscore t. So if you pass this into it, it will return the character star. Okay, I should have written it here, character star, which is the name that you passed during the creation time. Because if you remember, create task, you pass the task name. Okay, that task name will be returned here. So I want you to try it out, that function. Okay, these are all the way to explore more into using multitasking application, developing multitasking application. And then also I want you to get familiarized with the function. Okay, there is another function you can use. There's only sample for this experiment, but you can explore further. There is no limit. This is the state of the task. Suppose your task is, when this you are going to do, all this printout you are going to do from loop. Okay, loop function. Maybe I should mention that. Okay, let me do all this so that I don't miss out. This is returning character star. Okay, please stop me sometime, when you have some doubts. Use the following function to print the task names by passing the task handles in loop. Okay, loop function. Okay, and then inside that only the below functions also inside loop. Okay, inside is going to next page, next line, in loop. Okay, this will return some value, an integer value, which is nothing but an enum defined as task state. I want you to find this task state in the task.h, which is also defined here only in this header file, and then find out what is the state it is printing. See, when you are printing the loop, this task could be in different condition. I'll tell you what is happening. Your loop is, okay, I cannot write it here. Your loop is running as some task in core 1, whereas all your task 1, task 2 and task 3 are all running on core 0. Core 0, and they are all periodically running. So for a short time they will be running, and then most of the time they will be sleeping, delay. So when you try to print the state of each of the task, you might see that the task is blocked. You may get the value 2, which is equivalent to blocked, or if you are lucky, maybe you may get it as running, because there are two different cores. So there is a possibility that this on core 0, one task is running and the loop is trying to access the state of the task at that time, So it will print running. Okay, it is very random, very probability is very less, but try to analyze what is happening, what you observe, and make sense. Try to make sense out of it. Okay, that is the intent. Okay, just blindly run, try to explore and see what is happening, and you will know that the really two tasks are running on two different cores in parallel. That you will get it. We will do something else to even sense that, but this will be one way of doing it. This is one experiment. Okay, I hope you understood what is to be done. Even if you do slightly away from what I am saying, it's not a problem, but try to use all the functions that I have told you, and then try to stick to this as such, as much as possible. You can do more than this. Okay, any questions on this experiment before I go to experiment 2? No questions. Very good. Now, okay, this is clear, hopefully. Other one. Now, let me explain the background. We have a pin, ESP32, and then we have all the GPIO pins coming out here, GPIO. Okay. Now, I showed you a picture also earlier with all the pin details given. I will explain you which pin, where is it located, how to find out. It gives you different names, so I will tell you what is to be done. And then, if you remember, for the built-in LED, okay, built-in LED, we pass that pin number, and then we set it as output. Okay, mode, set mode or something. Okay, set mode or some function is there, which we use to make it output. Now, if you want to read input from the GPIO pins, okay, we are going to give some binary value 0 or 1 on a GPIO pin. Then we want to read it in the ESP32. So you have to set this as input, okay, for those pin number, okay, whatever pin number we identify. Then how do you give input? Now, this GPIO pins, they are all designed for 3.3 volts as a binary 1 and 0 volt as binary 0. So you are supposed to give only 3.3 volts and 0 volts, not 5 volt for sure. Okay, do not give 5 volt. Now you will wonder, how do I get this 3 volt or 5 volt? It is very simple. This ESP32 board has some pins which are ground and then 3.3 volts coming out, and then there is another one 5 volt and ground also coming out. Okay, do not connect it to 5 volt here. I want you to use the 3.3 volts. Now what is happening is, when you connect this board with the laptop on micro USB, it draws power from here, and then inside that it has a stabilizer and supply, and makes the 3.3 volts available for us, and 5 volt is also available for us. So this board is supplying us the voltage. So use that voltage what we get here from the board, and then give it to input, give it as an input to one of the GPIO pins, if you want to give a pin number 1 or a 0. Okay, I hope you understood this much. Now, what are the pins? I am saying pin number 16 and 17. Configure them as input. Bit 0 is pin number 16 and bit 1 is 17. So bit 0, bit 1, you know that what are the values you can give. So this values 0, 1, 2, 3, you have to read it from the pin, this GPIO pins, after setting it as an input. Okay, this input mode you will be setting it in setup function. Setup only you will be setting up the both the GPIO 16 and 17 as input, and then in the loop function, okay, you will be reading them. You will be reading these inputs. Okay, and then you will initialize on count variable, which is based on this value. You will set it up to 0 or 1. I leave it to you. How do you do it? Okay, you have to read these bits as ones and 0, and then you have to do it. Initialize it to some variable, integer variable count, and then what you do, once you do that, you implement a function called a blink LED. Okay, which is accepting the pin number as the built-in LED, because it is going to blink the built-in LED for, which is nothing but number 2 count value, how many times it has to blink, that is the count which you have taken from this bits. And then the delay, you have to define a variable called blink delay, okay, all capital blink delay, as some value. Maybe initially you can set it up as 500 millisecond. Now what happens is, somehow you are going to change the value of this bits to any one of them by your jumper wires. Then what happens is, this is going to be done periodically. It is going to read these bits every maybe 2 seconds or something, or you can keep it a little longer, okay, 4 seconds or something, so that it is going to read the value every 4 seconds inside the loop. Based on the count value, it is going to initialize the count value based on the pin it is reading, and then it is going to blink that many number of times with a delay of 500 millisecond. Okay, that is what you are going to implement it in this function, and you are going to call the function in this loop. So it will blink that many times and then again sleep for some time, longer duration. This delay you can design as a blank delay, blank constant, blank delay. You can set it up as 4 second or 5 second, I think I have given, and then you will be blanked out for some time, then it will blink that many times and then blank out for some time. So that is what you have to implement. So while this is doing, if you modify the input by changing the jumper connection to one of this from 2 to 3, then next time when it is reading the value, it will be blinking for 3 times. So you can see that what you do on a input, it will be blinking differently. That is a simple problem I want you to develop. Now let me explain what I am saying. Note that the operating voltage of these GPIO pins are 3.3 volts. Do not give 5 volt to it. Okay, one more important thing. This Arduino, if you want to interface it to Arduino, if you want to make Arduino talk to your ESP32 through some pins, suppose GPIO pins of Arduino and ESP32 pin, this level is 3.3 volts. I think, I am sure Arduino is 5 volt, okay, TTL level. So you should not connect from Arduino to ESP32 directly. It will spoil the board, okay. Keep in mind, there may be some other way of interfacing it, but not, you cannot control something from Arduino, maybe by changing some bits. Some program is running here and you want to modify the behavior of ESP32. It will be very interesting to do that, but GPIO, if you are doing, you need to do it in a different way, because you have to bring down the voltage from 5 to 3.3 volts, which is not directly usable. Okay, so please remember that when you are doing. Okay, fine. Now you need to know how do you do it. Now how do you connect it? I will give you explain the breadboard. Okay, I will talk about the breadboard and then I will tell you how to make the connection. Right now, let us not worry about it. You have to use these signals, 3.3 volts and ground pin, and then GPIO 16 and 17 from the board. Read in 2 bit of binary inputs, okay, and then initialize the value into count based on what you read from the pin. Write a function which accepts the following parameter: input pin number, which is nothing but the blink LED, because we are going to use our built-in LED only for blinking, and then count value what you have found from the input, and the delay time is what you have set as a defined as a constant, and the blink delay constant is 500 millisecond. You can set it up, and the above function will blink that count number of times with the delay time passed. Okay, based on the delay time it will blink, and there is a blank delay time which is 5 seconds. You can set it up. So call this blink LED function, whatever you have developed, as inside the loop function, so that it will make the built-in LED to blink that many times. Based on what binary input you are given, you give to the board, the blinking should happen. Okay, this is the output that you are supposed to show. I hope this is clear. Now let me tell you the pin numbers. If you keep the board like this, the pin numbers you can count it. These are the 3.3 volts and ground. Do not make a mistake. This is V in is voltage which you give in as an input, or sometimes this is giving out 5 volt also. So do not use this side. Okay, left side you should not use when you are facing the board like this. it should be this pin. Okay, and then GPIO 16 and 17 are here. Okay, so you need to connect the, you need to draw the things from this pins. Okay, you can count it number of times. So I will anyway share this PDF with you. You already have it. Now I will talk about breadboard. Breadboard, I hope all of you have. If in case if you don't have a breadboard, I don't know. It is very, it's not very easy. I don't want you to solder or something. You need to put a cello tape or something to connect and disconnect every time. It's a pain. Okay, I will explain you what is the, how do you do it with the pin, breadboard. See, breadboard normally has two lines reserved for power supply. In our case, one is for power supply, which is 3.3 volts. Another one is for ground. It could be black or blue. Okay, so you have a board. Okay, our ESP32 board. What you do? You are keeping it like this. I think I saw the ground and pin from here. So whatever the ground are 3.3 volts. Okay, you take a, underneath you connect a female jumper wire, and then connect the male side of this into ground here, and then 3.3 volts you connect it to here. Now what happens? You have brought the ground, and remember that you have to bring both ground and 3.3 volt into the board. Now once you bring it, what you can do is, it is available in all the places. The short means it is internally shorted. So if you connect 3.3 volt one of the wire holes, it is available anywhere. Okay, so you can connect, you can draw any 3.3 volts from any of the places. Now what do? You take GPIO 16 and 17. Okay, somewhere, suppose these two are the points. I think normally it is from this side only. So connect it to one of the things here. Okay, and then another one somewhere here. Now these, all these wire holes are connected internally. So if you connect it to one row here or column here, you can take another wire which is, sorry, I'm sure you know this, and then you can take it from here, two wires. Okay, that means you are trying to decide what is B0, what is B1. You either connect with another male to male jumper wire, either connect it to ground or a 1, here also ground or 1, then you can give 0 0 or 1 0 or 0 1 or 1 1. You can give it based on what you connect. Okay, that means you are feeding either, for this pin you are feeding 1 or 0, similarly for this. Once you do this, your connection is ready. Then you can start playing around. After downloading the program, you can just, you don't worry, you while running the program, removing the wire or connecting it back, nothing will happen to the board unless don't short it. So take one pin and then connect it to one you give, then you will see that 3 times it is blinking, this LED is blinking. Then 0 0, if you make it, it doesn't blink at all. You can modify the value of input that you give you by only changing these 2 wires. The other ones are not need to be touched, and these are also not to be touched. So this is how we can make a simple connection with the breadboard. Any doubt, please stop me anytime or ask me over the phone or chat or the chat window. So I hope this is clear. This is what you are supposed to do. Okay. I think this is,
Sir,
yeah, go.
sir, in experiment 2, I had a few questions.
Yeah,
Sir, first of all, the blink delay time is basically the time between the blinks, correct?
correct.
Okay. Next is the blank delay time is basically a dead delay time, right?
Correct.
This is system will not do anything at that point.
Correct.
Okay, understood.
So okay, let me tell you. This is the blank time, which is 5 seconds. Blink time is a small 500 millisecond. Okay, this is 500. Okay, I'm just showing it very small, not very relative. Okay, fine. So based on the count, now count is 3, then it goes up for some time, on for some time. This No, it is actually 500 plus 500. Okay, it's not very accurate, but it is going to change every 500 milliseconds. The same thing like our code, original code. So it will do thrice this blinking. Okay, and then it will be sleeping for, actually from here it will sleep for 5 seconds, not from here. Okay, maybe from here it will sleep for 5 seconds and then again start blinking that many times. By then, if suppose within this 5 second delay you have changed the input, then it will start blinking only twice or once based on what you are given as an input.